All right. Good afternoon, everybody, and welcome to today's webinar, where we will be deep diving into one of our projects focusing on how to turn waste into clean energy. My name is Emma Reinberg Jensen, and I will be hosting today's webinar. Here at Atmos, I'm responsible for our carbon offset offering. And with me today, I have the pleasure of having one of our project partners, Errol Irene, who is the managing partner of Samsun Avdan Waste Energy project. Thank you for joining us today, Errol.
Thank you.
We recently had one of those webinars that we're having today, which is always much appreciated from our clients, as it gives a rare opportunity to meet the projects themselves and get valuable insights and deep understanding for how carbon offsetting projects operate. Before we do deep dive into today's topics, this is our agenda for the next 30 minutes. If you're not yet familiar with Atmos and our full offering, I will start off by giving a brief introduction to us. Then we will explore how avoiding credits fits into your climate strategy and the beyond value chain mitigation framework presented by the Science Based Targets initiative. I will explain why methane is such a potent greenhouse gas and why it's important to tackle it near term. Then Errol will give us a thorough introduction to the Samsun Waste Energy project and explain how it works when they capture methane from the landfill gas. I will then have a conversation with Errol around the project, and by the end we will leave a few minutes to answer questions from the audience. So please do feel free to use the chat function to put any questions you might have. And as of house rules, this webinar is being recorded and you will be given access afterwards. And as I said, please do use the chat for any questions. And should you have any questions after the webinar, you are more than welcome to write them down in an email. I will be sharing my contact information at the very end. So what do we actually do at Atmos? Atmos offers an end-to-end carbon management solution, ranging from emissions calculations to offsetting. We have developed an intelligent platform that integrates directly to existing ERP systems, collecting the data automatically and transforming it into scope 1 to 3 emissions data. Our calculations align with the GHG protocol and are done all within minutes. We also support our clients in making transition plans, but as we know, so far we can't get around having unabated emissions. And therefore, we also help our clients finding the right offset projects or project portfolio to match their needs. Now, when it comes to carbon offsetting, we've been operating in the voluntary carbon market for 10 plus years and have helped our clients avoid or remove 2.5 million tons CO2. At Atmos, we do advocate keeping this as a complementary strategy. So while offsetting contributes to the solution, companies should not lose the focus on achieving direct emission reductions within the company's operations and value chain. And the way that we do support organizations in their carbon offsetting strategy is by facilitating offsets beyond the company's direct value chain. We offer credits that align with the Beyond Value Chain Mitigation Framework recommended by the Science Based Targets initiative. And we have been in this field for many years, so we have formed strategic partnerships with project developers around the globe. And this means we also do have a global reach of high integrity credits, offering both avoidance and removal credits from nature-based and engineered solutions. And the Beyond Value Chain Mitigation by Science-Based Targets initiative is a guide and framework for companies on how they can take responsibility for their yet unabated emissions whilst they're on their journey to meeting their reduction targets. Setting targets is a very efficient way to reduce global emissions, but as we have already, as of last year, exceeded the 1.5 degrees threshold in global warming, we are in great need of actions and solutions that reduce our global emissions even further. We can't rely on future solutions and targets that are going to be met 2050. Therefore, the BVCM framework has stated two main goals when it comes to mitigating emissions beyond your value chain. And these goals are: one, to deliver additional near-term mitigation outcomes to achieve the peaking of global emissions and the halving of global emissions by 2030. And the second goal is to drive additional finance into the scale-up of nascent climate solutions and enabling activities to unlock the systemic transformation needed to achieve net zero by mid-century globally. This means a company can essentially build a beyond value chain mitigation portfolio consisting of avoidance and removal credits to deliver on these two goals. And as shown in the graph by Science-Based Target themselves, you can see how the BVCM should be interpreted. If we see here, so this beige area is the BVCM, and if we divide it into the two pillars, the beige area is the avoided credits, whilst the purple is the removal credits. So this means essentially that the avoidance credits make up the majority of the batch, whilst removals are the last 10% by 2050. And as mentioned, and aligning with this, at Atmos, we do offer a selection of credits in our portfolio. We have both nature-based and engineered avoidance and removal credits. And today we are deep diving into our avoidance engineered solution credits from the Waste-to-Energy project. Now, what is so special about this project that we're diving into today is that it approaches and tackles methane. And methane is one of the most common and known greenhouse gases and is emitted during multiple processes from both human and natural processes and activities, but primarily from energy production, agriculture, and waste decomposition. And when tracking methane, we see that the amount in the atmosphere has increased rapidly in recent decades, but it's also estimated that 60% of today's methane emissions is a direct result of human activities. And the concentration of methane in the atmosphere has also more than doubled over the past 200 years. The International Energy Agency states that methane is responsible for around 30% of the current rise in global temperatures. And according to IPCC, methane has a global warming potential about 80 times greater than CO2 over a 20-year period, which makes it a very potent short-term climate forcer. And as it lives in the atmosphere for quite a short time, it has a short lifespan. Methane lasts about 12 years, unlike CO2. And therefore, it is very impactful if you tackle methane near term. So with that in mind, it's a pleasure of having Errol with us today, Managing Partner at Samsun Avdan. So Errol, this is a very interesting solution as you tackle emissions and environmental problems in more than one way, from a waste perspective, renewable energy perspective, but also tackling methane, which we just saw was such a potent greenhouse gas. So now, Errol, over to you. Please do walk us through what you actually do and how your technology works in practice.
Thank you very much, Emma. A very warm welcome from Istanbul, Turkey. Actually, it's really warm. It's almost 20 degrees in Istanbul at the moment. It's like a alarm clock that every morning warns us again that how much the climate has changed ever since in our short lifespan. I will be talking about our project, gold standard project that we tackle, collect methane and turn it into energy in the coming few slides, 6 to 7 slides in 10 minutes. And then, as Emma mentioned, happy to answer your questions at the end. We can move to the next slide, please. Our company is a focused renewable energy company, established in 2010 when we started this project in Samsun. We are producing biogases, so it's including landfill gas, biogas, etc., which has a fraction of methane inside. We turn them into electrical energy at the moment. In the future, we might switch into other technologies. We do waste management, landfill planning, construction, degassing of landfills, recycling technologies. We handle sewage sludge. We handle the organic waste in the industry. We take fish waste, manure, chicken waste in our biogas plants. We develop emission reduction projects. We grow flowers in our greenhouse, which we heat by the exhaust heat of our existing CHPs. Currently, we have 3 laboratories, one of them dedicated specifically on research and efficiency increasing procedures, let's say, for methane producing bacteria. So we look into microbiology of it quite in detail, collaborate with European partners or Spanish partners. We have German and Austrian partners that we work together. And all these years of accumulation and knowledge and experience, we try to develop capacity of the community around us. So we organize events, webinars, seminars, site visits, which everyone is more than welcome to come on and visit our sites. And we also have a visitor center, which we pass on this information to the next generation, which I will be speaking at the end of the slide quite shortly. We can move to the next slide, please. Our project that we will be speaking today is based in Samsun. Samsun is a city on the north of Turkey that you can see with this blue dot. It's a Black Sea. It's a seaside city basically. The landfill site opened in 2008. We have started our operations in 2010. Since then, we've been developing this project with the municipality and collaborating with the municipality. Our first electricity generation started in March 2012, which almost 15 years, 13 years ago. As you know, when we are starting these projects, gold standard is one of the first steps that you take, application to the registry and considering, informing that you're considering this project to be a carbon emission reduction project. So we have started communications with gold standard back in 2010. Can you move to the next slide, please, Emma? The project that we will be more specifically focusing on today is a gold standard project ID number 935, which is capturing methane, which is a part of landfill gas. So landfill gas is 45 to 55, I would say, okay, maybe 50% in average methane, has methane content in it. So it's a biological process. So that's why it's fluctuating every minute. So we capture the landfill gas generated from municipal solid waste, where the whole city's waste, household waste, is collected and basically deposited and turn it into electricity. We have a license to produce close to 55 million megawatt hours per year. And this project is basically avoiding methane to if we have not done anything, the organic fraction in the waste will decompose and emit to the atmosphere. So we are collecting this gas and preventing it to reach the atmosphere and stay there. Our gold standard project, as I mentioned, when we started the company back in 2010. It is in its third credit period. Another 5 years to go. Quite an old one. We've been in the market for the very beginning, have seen every ups and downs in the carbon market. We've done recently our 5th verification this summer, a couple of months ago, 2-3 months ago. So I've been in this project. I've been in the market for quite a while, and I'll tell you about more in the next slides. And we have accomplished, I think, a very quite a lot along this project. Can you go to the next slide, please? To give you a brief summary of what we do, basically, when we say about methane capture. So the waste that is collected in the city is shipped by trucks to the landfill site, and it is not on our project boundary. It's done by the municipality, but waste is brought to a landfill site, is compacted and placed in a huge area. Today we receive close to 900 tons of waste per day. Bigger cities like Istanbul, we speak about 10,000 or something. So what we do is that we do planning about where the waste should be placed, how high it should go, and what type of piping we need to install so that we get the highest efficiency on collection rates of landfill gas that is produced biologically inside the landfill body. So this is the first step is actually planning, measuring, mapping, and a little bit of engineering, calculating how much vacuum or under pressure we need to apply on the landfill side. So because it is kept under vacuum, the gas migrates into the pipe, not just emits through the surface to the atmosphere. So that's the first step. And then obviously all these pipes and microbiological activities and summer, winter conditions, it is not a standard production. It's fluctuating day and night. If it's rainy, if the atmospheric pressure is low or high, or if the waste characteristic change, if people eat more watermelons in the summer, or they have Christmas and you have turkeys in Turkey, and it's a different waste composition every now and then. But the engines at the end of the process has a standard protocol that they could utilize this gas. It needs to be pressurized so to a certain level. It needs to have a proper, let's say, acceptable methane content in it as a percentage waste or amount. Dryness maybe also. We are standardizing this fluctuating gas so that it's suitable for the CHP units to turn it into energy. That's how we do in this step number 2. We measure the gas, we monitor the gas, we prepare the gas, let's say, so to speak, pressurize it, and send it to the CHPs. And if it's not suitable for the CHP to burn it, then it is bypassed, sent to the flare, and burned in the flare so that it's not emitted back into the atmosphere. So in this small screen that you see in the middle and down in the middle third picture, we see the CHP percentage, CO2 percentage, temperature of the gas, flow meter in the gas, vacuum, that how much pressure we apply to the landfill side, if it's -30 or 35 or Normally, we work around -80 millibar. And then on the CHP side, what is happening? All these are documented and kept as gold standard. Wants us to record every there's intervals. It's in some protocol, I think it's in every half an hour or every 2 minutes. We record the gas flow meter, pressure, temperature, and methane content. There is a gas analyzer inside this unit, which measures automatically calibrating itself and measuring the gas composition. So everything is recorded, because eventually what is important is the amount of methane that we capture. It's not the total amount of landfill gas we collect, but how much of methane are we really capturing out of this this total volume. Can you move to the next slide, please? So over the years, we do this activity and then we record this data, as I mentioned in the previous slide. Today we can speak roughly, we are capturing close to 22 million cubic meter of landfill gas. If we assume it's half of it is methane, then we are talking about 10 million cubic meter of methane each year that we capture and avoid that it's released to the atmosphere. We produce electricity, which is also replacing fossil-based energy on the grid. Gold standard, under gold standard, as you all would know, there's SDGs that we are committed to do. We have 3 SDGs that we are following, and you can see it on the slide. We also have employees from the vicinity of our power plant, so we're creating decent work and equal rights for both men and women. What is also interesting in this slide that I would like to share with you is that we have been, ever since when we started this project back in 2010, 11, there was a start, and then the recording started when the CHP started, which is 2012, sorry. Since then, we have issued 1.2 million tons of credits that you see. So what does that mean? So roughly 1.2 million ton of credits, or amount of credits. So 1 carbon credit is 1 ton of CO2 equivalent. So this means we have been awarded by a certificate that is tradable, like by gold standard, that we have achieved to remove 1.2 million tons of carbon credits from the start of this project. And half of it have already been retired by the industry, where Emma has mentioned about how the corporates are reaching their targets, etc. So this is one of the tools that they could use. Half of it already been retired. The remaining half, the majority have been recently issued, so we're quite short on inventory. That's what it is in a nutshell of our project. You can reach, this is a public data, you can reach the details and on Gold Standards registry website. Can you move to the next slide, please? This is the last one that I will be sharing, but maybe the most important one that I would like to mention, because it's some of the activities that we've been talking about is past data. It is gas collected in 2021, credits have been issued in 2022, 2023. So it's everything what we've done in the past, properly recorded and properly documented. But what we do for the future is, one of the things is that we create awareness and we teach kids and students and university students sometimes, or colleagues of us, so that they take preventive actions for the future of the of this climate war, let's say, the fight that we are in. We've ever since we started this project, we have welcomed more than 14,000 students on our site, spending roughly 1 hour or 1.5 hours for every visit. Myself and my colleagues have spent so much of time telling what is global warming, why CH4 is a potent gas, why it needs to be removed. So if this is where I will be ending my short introduction. It's a huge topic that we could spend hours and days to speak about. I hope I have given you a little bit of a highlight. Happy to dig into any other aspect that you would like to hear more from us. Thank you very much.
Thank you, Errol, and definitely it is a very interesting topic, and there is so much to say, so it's hard to fit everything into just half an hour. But thank you for walking us through to understand a bit more about the technology and how it actually works. And you are being measured on so many different parameters when you are getting a certification by gold standard. You need to be showing additionality and which co-benefits you actually provide, which you mentioned. And I would like to know, because we don't have that many minutes left, what has been the biggest technical or operational lesson learned since you started this operation?
So can you just repeat the last one, because I just
Yeah, of course. The biggest technical or operational lesson that you've learned since you started the project?
So many lessons we've learned. It's one of the when we started this. We are not coming from this background. We had a great German engineer, consultant, who helped us to develop the project in the early times. And one of the problems that we face when in any, I think, industry, it's not that you have your okay, you need colleagues around you that will support you during the journey. So if this is in Turkey, it was when we started, it was at the very early time, so nobody was really experienced enough about how to operate a CHP or how to lay a gas pipe in the landfill. And then you're looking for employees, and employees have first, they hate to work in a landfill site. I mean, I still have. I remember once I took my family to the landfill site, and they said, "Oh, we thought you're really in a very bad environment," but it's not like that. So the experienced employees, it's very difficult. So we need to teach and increase their capacity. The know-how that is in the sector is not enough. So that was the biggest challenge, I think.
Thank you. All right, that is actually all we have time for today. With 1 minute.
There is a question in the chat box. Shall we take that one?
I think we will have to answer it by email as
okay.
we are running out of time. But thank you so much, everyone, for joining today, and thank you, Errol. And if you would like to learn more about this and look into the project, don't hesitate to reach out. We can book a meeting to learn more, and just shoot me an email. And with that being said, Thank you so much, and keep an eye out for upcoming webinars from our end.
Thank you very much.
Thank you.